Welcome back again. Elements lockdown special, new day, new element. Here we go. We are going to do beryllium. Hallelujah, we're on the next group. Now we've done group 1 called the alkali metals. We're about to start on group 2, the alkali earth metals. Now, before we go any further, I just think it's really important for you to understand what on earth this alkali is that I keep saying. What is alkali? Now, I always find the best way to understand something is to understand where the word came from. So, alkali, if we pull up sodium very quickly, that we did on, this was our 3rd video that we did, sodium. As you can see in the background, we have that green plant that loves salt, and alkali is an old Arabic word which is what they call the ash from those burnt plants, soda ash. And they discovered that it was very useful for all sorts of things. It was the mummification process, and it's used for ceramics, as in pottery. It's used to make soap. So it had a lot of uses, so they actually gave it a name, alkali. And you find that alkali, or things which are alkali, are on that side of the table. And a polar opposite to alkali, sort of, I'll probably be told off for saying that, but it's opposite, is acids, which are on this side of the table. Now, acids you're probably more familiar with, you've heard more. There's very mild acids like citric acid from lemons, acetic acid from vinegar, formic acid from ants, yeah. And then we've got some really heavy duty acids like hydrochloric acid in your stomach that you make yourself. And there's really nasty acids like sulfuric acid that's used in car batteries. We've got nitric acid, which is used in explosives, TNT. So we've got acids on this side, we've got alkalines on this side. What the beautiful thing is about alkalines and acids is they neutralize each other and produce a salt. Now, we use the table salt, it's the white salt, put it on your fish and chips. But salts, there's many different types of salts. But table salt can be produced by mixing the right alkaline with the right acid. For example, here's another example. If you have indigestion, heartburn, too much acid in your stomach, you will take an antacid, which is an alkaline compound from this side of the table. I'm going to do a quick experiment. I've got in here some bicarbonate of soda. Pick it up anywhere, any shop, and some vinegar. So all I'm going to do is very quick. I don't know how this is going to turn out. I haven't tested this out yet. I don't know how fizzy it's going to get. But can you see that? There's some. Here we go. All right, that's nice. You can see it fizzing away there. So that was vinegar, which is an acid from this side, mixing with bicarbonate of soda. There's the soda on this side, and they neutralize each other. Now, there is a scale where I know we're sort of getting off the elements a little bit. I think it's really important you get a sort of general grasp of this. There is a scale that was put together by Soren Sorensen called the pH scale. They think pH stands for power of hydrogen. Sorry. And here's the scale. Now, I've actually flipped it. I haven't changed anything. I've just reversed it because the scale goes from 0 over here, which is very acidic, to 7, which is over here, which is neutral, which is like water in your blood, and so on. And alkaline, which is over here, which goes up to 14. Now, on the normal graphs, they always put the acids that way. And anyway, so I flipped it. It doesn't matter. 0 acids, 14 alkaline, 7 neutral, water. Now, Søren Sørensen was, here he is, Søren Sørensen. He was a Danish chemist who came up with litmus paper to test to see if something was acid or alkaline. And you can make it at home out of red cabbage. But he used lichen. Here is some lichen. It's that weird greeny sort of, it's half mushroom, half algae sort of plant. Anyway, he ground it up using probably something like this, being a Dane. This is mealner. Okay, forget that. Buy it on the internet. Litmus paper on the internet. Forget about making it yourself. And he invented litmus paper, and it will tell you with its colour change whether you're dealing with acids or alkalines. Okay, bingo. So there is a broad outline of what makes things acid and alkaline. Okay, okay, cool. Let's pull up beryllium. Finally, we are at the top of group 2, and here is beryllium. Louis Nicolas Vauquelin, here he is, discovered beryllium in, I think it was 1798. Now, if you have a look at the card, first of all, you recollect that there are some patterns going within the table there. Now, if we have a look over here, we've got boron and beryllium and lithium. And if you remember on lithium, on one of our first videos that we did, they've all got a similar background, because beryllium is made by a thing called cosmic ray spallation, which is rays from the cosmos come down, hit an element and turn it from one element into another. So that's why it's got the similar background. Now, have a look at this picture here. Now, this is a periodic table showing how much elements there are on the Earth, and you can see that there is like there is a lot of iron, carbon, oxygen, represented by these really big blobs. But there is beryllium up in the corner. It's quite rare, so it's quite expensive. And if you look at the card again, you'll see its atomic number is 4. So we are now back to being really light elements. And that means it's very useful for some things. I'll go into that in a second. So its atomic number is 4, which means it's got 4 protons in the centre, 4 neutrons and 4 electrons whizzing around it. Now, it's not often found in this state because it's quite unstable. I'm not going to go into it at the moment. There's a thing called isotopes, and isotopes are just where you play around with the neutrons. There's not as many neutrons in the centre. It's the protons which define an element. They never change. The electrons go wandering off. The neutrons can be different as well. But beryllium is quite unstable. That's why there's not a lot of it on Earth. And in a star where it's produced, it also tends to very quickly degrade into another element. So it's quite rare, so it makes it quite expensive. Now, having only an atomic number of 4, it's really light, which makes it very useful. And one of the things it's used for is in the making missiles and aeroplanes and gyroscopes and anything where you need something which is very shiny, by the way, and brittle, so it makes awesome mirrors, lightweight mirrors. In fact, here's a picture of the James Webb telescope. Now, this is going to be the next telescope which is going to come after when they finish doing it, building it, which is going to come after the Hubble Space Telescope, which is up there at the moment. And it has these huge hexagonal mirrors which use beryllium because it's very light and they can polish it up. It's brittle, but it's light. Now, the next thing to have a look on the card is this here. Can you see this X-ray? Yeah, right, okay, there's a blue line going through his head. Now, this represents X-rays. Now, you've probably all heard of X-rays. Break your bones, go and have an X-ray. Now, X-rays are a form of radiation. Now, there's a few cards with X-rays on. I'll pull them up. So you've got beryllium up here with an X-ray going straight through him. Whereas barium down here being absorbed by X-rays. And over here we have lead also being absorbed by X-rays. And selenium, you may have heard of selenium, anti-dandruff shampoo. And very important for your body. But anyway, if X-rays are hitting selenium, which incidentally cause it to produce electricity, but that's for another day. So if on any of the cards you see this blue thing shining through, that's an X-ray. And the red line is an infrared light. So infrared light doesn't go through beryllium, but X-rays do. So with X-rays being able to go through it, it's a really useful piece of equipment in laboratories, because say if you had something you wanted to analyze and you needed to put an X-ray through it, but say if it was like a gas, how would you contain that? Well, you could contain it in a beryllium chamber. So the X-rays would go straight through, analyze or test whatever it is you wanted to test, and shoot out the other side, and not be affected by the beryllium. Simple as that. Very handy piece of kit, but expensive. Another thing you'll notice is these sparks. You see the sparks in the corners there, not the background, but the sparks. Now those are, what they mean is if you mix beryllium with copper, which is over here, you get a very strong alloy. Alloys are where you just mix different metals together. But you get a tool which is strong and hard, but it does not make any kind of spark, which is really useful if you're working somewhere where sparks are a bad thing, like in pools of petrol or gas, or something where sparks are a really bad thing. Now, the name beryllium comes from the gemstone, beryl. Not Aunt Beryl, beryl. And beryllium, the gemstone beryl, used to be made into glasses still, because they used to make it out of beryllium. Right, I think that's all I've got to say about beryllium at the moment. Thank you so much for all the kind comments that you've put up in supporting this endeavour. We're going to try and put one out every 2 to 3 days. It takes a little bit longer than what I thought it would be. A 10-minute video takes a little bit longer. Anyway, we're going to crack on with it. We're going to try and go through all of these 73 elements. Just as a reminder, there are more elements, but we don't talk about them. If you want the artwork for this emailed to you in high definition, free of charge, just go onto the website elementskapa.com, leave me your email, I'll ping it to you, and please subscribe and do that like business, so you'll get a notification every time a new video comes up. So thanks a lot. We'll see you next time for our second element in the alkaline earth group, magnesium. All right, thank you and keep safe. Bye.